Here I want to talk about validation, how we validated the ANSYS model. And if you recall, validation is looking at whether the mathematical model we have represents the physics accurately. Are the physical principles in the mathematical model sound, and are the assumptions acceptable? And for that, we turn to experimental data, and we have two kinds of experimental data here. The first kind of experimental data that we use for validation are strain measurements from strain gauges. This is from the lab that I referred to in pre-analysis that is done by mechanical engineering majors at Cornell. And they take the bike crank model and they put strain gauge rosettes on it. And so they get 6 strain measurements. Here I've shown the measurement from one group and from one of their strain gauges. And this shows the the strain in the particular direction in which the gauge is oriented. And this is the microstrain. So the actual strain is 10 to the power of, this times 10 to the power of minus 6. And the strain is, is a non-dimensional quantity. So the experimental value was 351 microstrains for, I believe, one of these gauges on that rosette. And, there's, they look at the margin of error. And the corresponding ANSYS value, which you can extract from the ANSYS results, is 311, and there's 11% difference. And the ANSYS result compares very closely with beam theory. So this is our hand calc, this is the experiment, and that's ANSYS. This is ideal scenario, where you have all three. The difference is possibly because of wobble in the support in the experiment, and also the location of these gauges is measured not too exactly, and that introduces an error. So it's important to think about why you get that mismatch. There's another way we validated it through this new technique called digital image correlation, and this was done by Jenny Borshoff at who was when she was a student at Cornell, and she was interning at a local company, Data Point Labs, that does material testing, and they have a very nice digital image correlation setup. And digital image correlation, the idea is use digital cameras to track points on some particular face, and from that how much each point has moved, and then you can back out the strain. And Jenny and the Data Point Lab staff, they measured what the strain, the normal strain in the x direction, so x is in that direction, and that is the strain in percentage. And here's the corresponding ANSYS result. That is just the strain. So you have to multiply this by 100 to get this value. And the scales are the same. And you can see that you get a very close match between what you get from the digital image correlation and what you see in ANSYS. Here, where you have the support and so on, where you have the support and the load, you don't get data from the digital image correlation. But that was a very nice way of validating the ANSYS model using a very modern technology.